Hello students, welcome you all to the video lecture on signals and system. Today we are going to compute the Fourier transform of given expression, that is x of t equal to e power minus 2 modulus of t minus 1. So whenever they give modulus of t minus 1, so meaning that the t here it varies from 1 to infinite. So for example, since they have given t minus 1, so we have to equate this value to 0, so t is equal to 1. So instead of 0 to infinite, here the exponential signal will vary from 1 to infinite in the positive side. So since they have given t equal to t minus 1, we have to assume your limit in the positive side as 1 to infinite. And again, since they have given modulus, so we need to consider the limit in the positive side also, negative side also. So one of the limit, it is t greater than or equal to 1, meaning that t varies between 1 to infinite. And then since they have given modulus, the positive side we have considered, similarly we have to consider the negative side also. So the negative side in the other part of the range we have to consider. So since we have taken from 1 to infinite, so already from here 1 to infinite we have taken. So what are all the remaining range that we have to consider for the another set of the integration. So what is the remaining range? It is from minus infinite to 1. So this range is another range, minus infinite to 1. So another range, it is t less than or equal to 1, meaning that we have to take the t range from minus infinite to 1. So like this we have to split your integration into two limits. One is 1 to infinite, another one is minus infinite to 1. That is the first step we have to identify. So generally they will give e power minus 2 modulus of t like this. If it is so, what we will take for positive side, we have to consider 0 to infinite. For negative side, we have to consider minus infinite to 0. This is the thing usually we will consider. But since here it is t minus 1, we have to consider the range. One range as 1 to infinite, another range as minus infinite to 1. And then since we are considering the positive limits of t, we have to consider here the term as positive values. So here the x of t, whenever this is positive value, here the value will not get affected. So we have to consider it as just e power minus 2 t minus 1, as it is we have to consider. And then negative limits, for negative limits, that is from minus infinite to 1, we have to change your sign. That is here instead of minus we have to consider it as plus 2 of t minus 1. So you have to consider this properly. So for positive limits there won't be any change in your value. So e power minus 2 of t minus 1. For negative limits, minus will become plus. So it is plus 2 of t minus 1. So like this we have to consider. So once we have understood all these things, now we can apply the Fourier transform formula and we can find out the Fourier transform. What is the general formula for Fourier transform? It is x of e power j omega, which is given by minus infinite to infinite x of t e power minus j omega t dt. And since the integration is ranging in the two ways, one is from minus infinite to 1, another one is from 1 to infinite. So for minus infinite to 1, what is the value of x of t? It is e power plus 2 of t minus 1. And then in the formula we have e power minus j omega t dt. Then plus, for 1 to infinite, what is the value of x of t? It is e power minus 2 of t minus 1 into, what is the formula? E power minus j omega t dt. So in this way we have to consider your limits properly and the value of x of t properly before proceeding the problem. So once you have determined all these things, now it is simplification and then the integration part that you can do easily. So now simplify this term before proceeding with the integration. Similarly, simplify this term before proceeding the integration. So, minus infinite to 1, and then so simplify this, we have e power 2t, that is split your exponential term, e power 2t into e power 2 into minus 1 is what? Minus 2. So, it is e power minus 2, and then e power minus j omega t dt. Similarly, in the second term for 1 to infinite, split this term, it is e power minus 2t, minus 2 into minus 1, it is plus 2. So, e power 2 and then e power minus j omega t dt. So, now minus infinite to 1, what are all the constant terms available? Whichever the term is not having t, that is a constant. Here it is a constant, here this term is constant. So, those terms you can take outside. So, it is e power minus 2, and then these two terms I can combine. While combining, since the limit is with minus infinite, I have to take t outside. So, already in the previous problem also we have discussed, right. So, why? Because I am taking t outside means whenever I am taking t outside only, if I substitute t tends to infinite, what happens? T tends to minus infinite, what happens? E power minus infinite will become 0. Why? Because in the limit I have minus infinite. So, whenever in the limit I have minus infinite, I have to take e power t. If suppose in the limit I have infinite, I have to take e power minus t. Why? Because when I substitute infinite here, e power minus t means e power minus infinite will become 0. So, I should not get infinite term, but I can get 0 term. Okay. So, you have to make sure that whenever in the integration limit I have minus infinite, take t outside. Integration limit, if it is plus infinite, take minus t outside, so that I will get e power minus infinite term, so that it will become 0. Suppose for example, if you take instead of plus t, if you take minus t outside, and if you substitute minus infinite again, what happens? E power infinity will become infinity. So, you should not do like this. So, in the limit if you have minus infinite, take t outside. In the limit if you have infinite, take minus t outside. Okay. So, that you have to understood. Then coming to the constant term, you have taken outside. Here t I have taken outside. So, what are all the other terms here? Here it is 2. Here it is minus j omega and then dt. Then 1 to infinite. Here the constant is e power 2, take that outside, e power, since we have minus infinite, I have to take minus t outside. So, when you take minus t outside, what are all the constant term? Here it is 2, here it is plus j omega, because minus t I have taken outside. So, it is plus j omega. So, now you can proceed with the integration part. So, here it is e power minus 2, just compute the integration. So, what is e power at? Integration of e power at, it is e power at by a, that is t's coefficient. So, similarly it is e power t 2 minus j omega, t's coefficient is 2 minus j omega, that you have to divide, and then what are all the limits? Minus infinite to 1. And coming to the second term, it is e power 2, just integrate this term, e power minus 2 of 2 plus j omega. So, t's coefficient is what? Minus of 2 plus j omega. So, now apply your limits. What are all the limits? 1 to infinite. So, once you have done that, here it is e power minus 2, take that outside as it is, substitute your upper limit e power 1. So, you can leave 1. Okay. So, it is 2 minus j omega, just 2 minus j omega. So, 1 into any term, that particular term, divided by 2 minus j omega. Now, substitute your lower limit. When substituting your lower limit, you have to introduce one minus and then e power minus infinite. Infinite into any term is infinite. So, you are keeping it as e power minus infinite 2 minus j omega. So, this is for the first term. Then coming to the second term, it is e power 2. Substitute your limit e power minus infinite. Infinite into any term, it is infinite, divided by minus of 2 plus j omega. Then already I have to introduce one minus for your lower limit, and here also one minus is there. So, minus into minus will become plus. So, e power minus of, substitute t equal to 1, 1 into any value is that particular value. So, 2 plus j omega divided by 2 plus j omega. So, once you have substituted both your upper limit and lower limit, I have these terms. Anyway, I know that e power minus infinity is 0. So, this term becomes 0. this term also becomes 0. So here it is e power minus 2, that remains same as it is, and here in the numerator I have e power 2 separately and then e power minus j omega. I am splitting your numerator. So e power 2 and then e power minus j omega divided by 2 minus j omega. This is the first term. And then coming to the second term, it is e power 2. Then again as usual split this numerator term, it is e power minus 2 into e power minus j omega, e power minus j omega divided by 2 plus j omega, divided by 2 plus j omega. And again we know that e power minus 2 into e power 2, it is 1, meaning that this and this get cancelled, it becomes 1. So this and this get cancelled, similarly this term get cancelled. So I am getting in the numerator as e power minus j omega. So this is e power minus j omega divided by 2 minus j omega, and coming to the second term, it is e power minus j omega divided by 2 plus j omega. So if you want, you can stop here, or else again you can take the LCM and you can simplify. So denominator, the LCM, it is 2 minus j omega into 2 plus j omega. So just cross multiply, here it is e power minus j omega into 2 plus j omega and then plus e power minus j omega into 2 minus j omega. So denominator, it is a minus b and a plus b formula. So what is a minus b into a plus b? It is a square minus b square formula. So using that I can write that it is 2 square minus j square omega square in the denominator. So multiply and simplify your terms in the numerator. So 2 into e power minus j omega and then e power minus j omega into j omega. So it is plus j omega into e power minus j omega, and here it is again plus 2 into e power minus j omega, and then plus into minus, it is minus j omega e power minus j omega. So anyway, here also e power minus j omega, here also e power minus j omega, but here plus j omega minus j omega. So this term get cancelled. One is plus, one is minus. So these two terms get cancelled. And then we know that j square value is minus 1. So minus into minus 1 will become plus in the denominator. So 2 square, it is 4, and then here one minus already available. So minus j square, it is plus 1. So I can write this term as plus omega square in the denominator. And then coming to the numerator, here 2 e power minus j omega, here 2 e power minus j omega, it is nothing but 4 e power minus j omega. Both the terms are same variable. So add your constants, 2 plus 2, it is 4. 4 e power minus j omega divided by 4 square plus omega square. So this is the final answer for the given problem. So this is your x of e power j omega, that is a Fourier transform for the given problem. Okay. Thank you. Thanks for watching.